Hey, this is Josh from Leet, where we explain Leet code problems as simple and concise as we can. Today, we're going to be talking about the palindrome linked list question. According to Leet code, in the past 6 months, this question has been infrequently asked by Microsoft, Amazon, and Facebook. So this wouldn't be a bad problem to know how to handle. In this problem, we're given a linked list, and we have to return true if it is a palindrome or false if it's not. So as a reminder, a palindrome is a string that reads the same forward and backwards. So for example, if we look at example 1, we're given 1 and 2. If we reverse this, we get 2 and 1, which is not the same. Now, if we were to look at example 2, we have 1, 2, 2, 1. If we were to reverse this, we would still get 1, 2, 2, 1, which means this is palindrome. We're going to answer this question using a O of n space solution and also answering the follow-up question, which requires us to use O of 1 space. There are a couple of ways of solving this problem. One example is that we just reverse this linked list that we're given and then just compare the nodes from beginning to end and see if they match. If we match, we have a palindrome. One other solution I like is to just store everything inside an array, iterate through our linked list, store everything inside an array, and then once we have an array, we can do a comparison with the front value with the back value, and then inch forward until we reach the middle. And if everything is the same, then we have a palindrome, otherwise we don't. This solution is a O of n runtime because we are linearly scanning through all of our elements. However, space-wise, it is O of n because we need to either create a new linked list for us to reverse or create a new array list to store our linked list values. The follow-up question wants us to solve this problem using only O of 1 space. What that is hinting at us to do is we have to do pointer manipulation with our list nodes. Otherwise, there's no feasible way of being able to solve this problem. We know if a number is a palindrome if their front number is the same as the back number, and if we just continue moving both pointers forward, we would be able to identify if the linked list is a palindrome or not. Unfortunately, it's a singly linked list, which means we can only move forward. So we cannot compare our back to our front. However, what we can do instead is we can reverse this. However, if we are able to reverse the second half of our linked list, like so, then we would actually be able to do a side-by-side comparison from the middle. If they are all the same, then we have a match. Now, how can we accomplish this? Well, first, we have to find the center. We can use a slow and a fast pointer to find the middle of our linked list. The slow pointer would only move one node at a time. The fast pointer would move 2 nodes at a time until we can't make any 2 nodes anymore. The idea is that we would move both pointers at the same time until we can no longer move the fast pointer, because that is the pointer that will reach the end. And once that happens, we know we found the middle node, or specifically the node before the middle node. And that is important because if we want to reverse the order of the linked list, we have no way of changing the starting node itself unless we have the pointer before it. What happens if we have a odd linked list? Let's draw an example. So here's an example with an odd number linked list. We move our slow pointer forward 1, and then we move our fast pointer forward 2. And now because our fast pointer can't move anymore, we have found the middle. And that makes sense because in a palindrome with odd numbers, the middle number is already a palindrome, so we would only need to compare the 2 side ones. So in this instance, if we had more elements here, we would just reverse the second half of our list, and then we can do our comparison. Now that we found the node right before our middle list item, we need to reverse the second half of our linked list. We'll go into the details more on the live coding section. However, if you're curious, we also made a video recently about reversing linked lists, which you can find on the top right corner. Now, let's assume we reverse the linked list. Now, after we reverse the linked list, we just need to compare everything from the middle and the front until we reach the end. So in this instance, this pointer represents our front, and we previously had our middle pointer. We just need to compare its next value with our front pointer. All we need to do is we would check the value of both nodes on both our pointer. If they're the same, we continue, and then we do this until we reach the end, or we find something that doesn't match, and if it doesn't match, that means we don't have a palindrome. And that's how we would solve this problem. Now let's see a live implementation. Let's get started. The first thing we need to do is to watch out for a null case. If we have a null head, that means we automatically have a palindrome. Now, just like what we talked about before, the first thing we need to do is we need to find the node before middle. So I'll define a helper function to do that. So like we talked about, we'll use a slow and fast pointer, and we will keep moving them one at a time until our fast pointer can't be moved anymore. So on the whiteboard right now, we have our head, which is, and we have, let's use blue to represent our slow pointer and green to represent our fast pointer. So we start out, we define them both. While inside our while loop, inside our find middle, we will move our slow 1 pointer over, and we'll move our fast 2 pointers over. Then in the second iteration of our while loop, we'll check to see if we can move our pointer 2 nodes forward, which we can't. So that means we've reached the end of this, and our slow pointer is now at the node before middle. Now that we have our middle node, we just need to reverse the second half of our linked list. So we'll also define a helper function to do that. Note that we want to pass mid.next, which is the second half, because mid is the last node of the first half of our linked list. We're going to use a current node to keep track of our header because we will be rearranging our nodes. Now, once again, if you want to see more in-depth detail, check out our other video about reversing linked lists to see us talk about this in more detail. Instead of explaining it over again, I'm just going to code it out. So to quickly walk through this, we have the head inside our reverse function, which is right here, which is pointing to R2. We have cur, which also points to head, and then we'll go into our code. So while current is not null and current.next is not null, we will create next. The idea to reverse the linked list is to take the node next to your current node, which is this one, and then move it in front and then change the pointers around. And the idea is to move it in front and change the pointer so that 1 is now in front of 2. So that 1 points to 2 and 2 points to whatever 1 is pointing to. So to accomplish this, we will move current.next to be our next.next. So this node will now point to null because our one node is pointing to nothing. And then our next.next would be head. So we move that over here to point to 2. And then we change our head to point to next. So following this pointer, we have head points to 1, which points to 2, which points to nothing. And then once we have that rearrangement, we return our head. It's important that we return the head variable because whenever you are changing the node itself, we will actually lose track of part of the pointer. So we have to return the variable that we're changing and make sure that we're setting it appropriately like we did over here. Now, let me quickly clean up the board. So now we finished step 2 and we reversed the second half of our linked list. Now we just need to compare the front nodes with the middle node and see if they are, and then iterate through to the end and see if they are the same. So the first thing we do is we create a current node. And then we move our mid to be mid.next, which is the second half of the linked list. So now we're comparing the first half of our linked list with the second half of our linked list. We want to iterate through our linked list until our mid reaches the end, which is when it becomes null. And then we want to compare our values. If they are not the same, we don't have a palindrome, so return false. Otherwise, we keep moving them forward until we reach the end, and then we return true. So right now on our board, 1 is the same as 1, so it's still a palindrome. We move everything forward. 2 is the same as 2, so that's the same. Then we move everything forward. And mid is now null, so we exit our while loop and return true. One thing to note that this algorithm does do is it changes the given list node that we're given. We permanently change the structure of our linked list. The problem itself didn't say to not modify the linked list or ensure that the linked list remains in the same state. However, in a real world application, it's probably never a good idea to modify the data structure that you are iterating through. All right, now let's submit our answer. And that's it for the palindrome linked list question. Honestly, for how involved it is, I really don't think it's an easy question, but LeetCode works in mysterious ways. Moving on, if you have any questions, please leave them in the comments below. Otherwise, if you like this video, consider hitting the like button and maybe even hitting the subscribe button to get daily updates. Otherwise, I'll see you in the next video and have a wonderful day.